Welcome to Ask and Learn.
In this problem, and actually the rest of the problems in this chapter, are kind of three-dimensional problems, and I'm not going to attempt to draw, to reproduce the figures here, um, but I'll refer to them as you can see them in the book. So this first problem, we have a uniform load, has a mass of 600 kilograms, and is lifted using a uniform strongback, which is basically just a beam that expands across the load. So then we have this beam here, and we have a cable here lifting the load, and then we have some ropes attaching down and going around this load here attached to this beam here. And these ropes, if you look at the other direction, those ropes are at, if you look at the other direction, those ropes are at an angle with the, so that they go from the center here to the corner of the package. So we can, in this problem, is actually very, very simple. They ask for the force that is in the cable lifting the entire system. And since the package or the container and the strongback beam have both have mass, and we can just draw a force balance on that, and we know that we have the total weight of the package acting here, the weight of the strongback here, and then that has to be offset with the force applied to lift it, and that turns out to be that basically it's just the total weight of the system is 6.18 kilonewtons. Now, we can look at they're asked for the tension in the cables, so the cables that extend from the center here down to the corners. So each cable, there's 4 of them, one on each, 2 on each side, and we can see that they make a 3-4-5 triangle. So if we're only concerned about, we can just look at the tension in the vertical direction. And so we have 4 of the cables, each has a tension T, and the vertical component is 4/5 of the total. And they must counteract the weight of the container, because the weight of the strongback is not, if we draw a free body diagram of the container, the weight of the strongback is not present. So we just have its mass, and then we have 4 loads acting up from the cables. And basically then we just get another equation, it's for T, and we can solve that. So the tension in each one of those cables is 1.84 kilonewtons, and we kind of expect that. Again, we can see that this is in a reasonable ballpark for what we would expect these tensions to be.